behalf of Scailyte, it is my privilege and my pleasure to welcome all of you here today. It is a very special day and an emotional day for Scailyte as we celebrate our 5th anniversary. And 5 years may not seem as a long time, but actually in the lifetime of a startup, it's actually quite a lot. And in these 5 years, we have achieved significant traction and we have pioneered the use of single-cell data for clinical discovery. And what better way to celebrate our 5th anniversary than hosting a unique event that brings together hundreds of people that share the same passion. And this is the passion that we have to help patients by turning scientific breakthroughs into clinical applications. And the topic of today's symposium is machine learning meets multi-omics for precision medicine. Precision medicine, in very simple terms, means giving the right treatment to the right patient. And it is an easy sentence to say and to imagine, but actually that's quite a challenge in healthcare. Because giving the right treatment to the right patient means that you know who is the right patient for the right treatment. And this is the question that is still unsolved. Which patients respond to which treatment? And why do some patients that have the same disease and receive the same treatment respond in a different way? And this is still something that we're facing as a challenge today, and this remains to be solved.
It's not too much to say that there is a plethora of single-cell technologies available for multimodal analysis of cellular phenotypes at the moment. So this diagram described, just off the top of my head, or what I could think of yesterday, as various experimental techniques to draw multiple different types of measurements from the same cell. And in a relatively short few years, we've moved from single-cell RNA-seq, which a few years ago was seen as state-of-the-art, to now it's being fairly old hat technology, and you want to be able to combine single-cell transcriptomics with other types of omics as well.
And when the paradigm recognizing these different T helper cells came about, people thought, well, RA must be a Th1 disease, an interferon gamma disease, because it's not like an allergic disease. That probably turns out not to be true. Subsequently, other T cell helper cell subsets were identified, like Th17 cells that make IL-17. And so actually 2 clinical trials were carried out because RA was thought possibly to be a Th17 disease. This also did not work out very well.
So if you look at healthcare over the past 10 years, and I guess the main reason why we're all here today is that you see a dual revolution ongoing. On one hand, you have an explosion of data. So imagine clinical genomics, imaging, clinical data, single cell sequencing, tomorrow, digital pathology, proteomics, you can add on, right? So there's literally an avalanche of data. On the other side, you have an avalanche of new tech recipes to make sense of that data. Think about all of the AI, machine learning, deep learning solutions. So by now you would imagine that we've solved precision medicine.
In thinking about clinical research in particular, one of the biggest problems we saw early on was that patients, or rather clinicians, can take a biopsy, and then how do you break that biopsy tissue down into a single cell suspension to be able to even measure the single cell gene expression?
So we can do a lot on the explorative phase. Yeah, we can collect biopsies, we can collect serum samples. We can align with centers of excellence to control the quality of the samples, to ensure that we have good input data. So there's a lot that we can do. But once you want to really bring it to the market, and the platform is not globally available, means in the US, in Europe, and in Asia, we really stuck.
More than the machine learning part, the difficult part is the data part, right? So as humans, we've evolved quite well on the machine learning part. We're not over the last 20 years, but on healthcare data, we've had difficulties standardizing data across all of the hospitals, breaking silos, making sure that data is brought together and that we can all learn from the aggregates and not just within our own.
Having machine learning and is as good as the amount of data that you have, right? So I think we discussed some of it during this symposium. I think starting to collect patient data in a formatted way so that we can interpret the results, I think it's key then in the long run to make some predictions.